See, forward blocking mode of operation. I discussed what exactly reverse blocking mode, what is the observations in reverse blocking mode that I discussed. Now see the concept of forward blocking mode of operation. Okay. In forward blocking mode means you want to make anode to cathode voltage is positive. If you want to make anode to cathode voltage is positive means anode is connected to positive plate, cathode is connected to negative plate. Now with this bias, what is the observations? Still I am not connecting the gate supply. That is gate current equal to 0. Still we are not connecting any gate supply, then gate current equal to 0. Now see, what is the observations in forward blocking mode of operation? Every point is important. Under forward blocking mode of operation, positive is connected to P1. This is positive plate. Majority carriers are holes. All these positive charge repelled from the positive plate crossing the J1 junction. That means majority carriers are crossing the J1 junction now. That's why J1 is forward bias or reverse bias. Forward bias. Negative plate is connected to N2. Because of negative plate is connected to N2, majority carriers in N2 layer is electrons. All these electrons are repelled from the negative plate, then crossing the J3 junction. Then J3 is forward bias. But what about J2? Because of this potential, these electrons are attracted from positive plate. These holes are attracted from negative plate. Then is it carriers are crossing the J2 junction? No. Then majority carriers are not crossing the junction. That's why J2 is treated as reverse bias. That's the first observation. Under forward blocking mode of operation, J1, J3, forward bias. What about J2? Reverse bias. This is the first observation. But I want to write one generalized statement. That is, outer junctions are forward bias. Outer junctions are forward bias. And inner junction is a reverse bias. Very important statement. In most of all the competitive exams, this model of question is already framed. If reverse voltage is applied, which junctions are forward bias, which junctions are reverse bias? If the forward voltage is applied, which junctions are forward bias and which junction is reverse bias? These models of questions already framed in competitive exam. Concentrate. Every point is important. Then you can easily analyze. We can take the switch concept. Let us assume that J1 acts as a one switch and J2 also acts as a one switch and J3 also acts as a one switch. Okay. Then now the SCR is under which mode? Forward blocking mode. Okay. This J1 is forward bias, means closed. This is anode. This is cathode. Then J2 is reverse bias, open switch. J3 is forward bias, closed switch. Even though J1, J3 is closed, still J2 is open. Still J2 is open means it is conducting or blocking? Blocking. That's why in forward blocking mode also SCR acts as a open switch. Hence it also blocks forward voltage. And this is the difference between diode and SCR. Concentrate. What is the difference between diode and SCR is? SCR blocks the forward voltage, but diode will not block the forward voltage. That is the main difference. That means SCR acts as open switch. SCR acts as open switch. Acts as open switch. Open switch. And blocks forward voltage also. And blocks forward voltage also. And blocks forward voltage also. SCR acts as open switch and blocks forward voltage also. Already it blocks reverse voltage, it also blocks forward. That's why it is bipolarity device. Understood? That's why it is a bipolarity device. Okay. Then third observation. Once it acts as an open switch means, is there any current from anode to cathode? There is no any forward current from anode to cathode. But practically, because of minority charge carriers, a small leakage current is exist. Then that leakage current is called forward leakage current. This is the observation from the characteristics. Still, I am not applying forward breakdown voltage. If the applied voltage is less than the forward breakdown voltage, practically a small leakage current is passing through the SCR. This leakage current is called forward leakage current. Therefore, there is no current from anode to cathode. There is no current from anode to cathode. But practically a small forward leakage current is exist. A small forward leakage current is exist. This small canal shown in the characteristics, that is nothing but a forward leakage current. Okay. Now see the fourth observation. In order to make the diode is turn on, if you continuously increase the forward voltage, if this forward voltage is continuously increased, we know that every junction is having its own withstanding capability. Then if you continuously increase the forward voltage, at a particular voltage J2 is breakdown, then SCR comes into forward conduction mode. This type of triggering is called forward voltage triggering. Like this we can make the turn on of SCR. That means if the forward voltage is continuously increased, whenever voltage is reaches to forward breakdown voltage, then J2 is avalanche breakdown. Here also avalanche breakdown. Sir, you told that avalanche breakdown means by applying reverse voltage. Yes, even though it is a forward voltage, with respect to this voltage, J2 is reverse pass. That's why it is a reverse voltage across J2. That's why J2 is also avalanche breakdown. J2 is avalanche breakdown, then the thyristor starts the conduction and comes into forward conduction mode through this path. It comes into forward conduction mode. That is, if VAK greater than or equal to VFB0, if VAK greater than or equal to VFB0, what happen? J2 is breakdown. J2 is avalanche breakdown. J2 is avalanche breakdown and comes into forward conduction mode. It is called forward voltage triggering. It is called forward voltage triggering. Like this we can make the turn on of SCR. This is one method of triggering of SCR. That is, forward voltage triggering is one method of triggering of SCR. Applying forward breakdown voltage, bringing the SCR into conduction mode is called forward voltage triggering. Applying forward breakdown voltage, bringing the SCR into conduction mode is called forward voltage triggering. Like this we can make the turn on, but practically this method is not preferable. Why? Because by applying breakdown voltage, bringing the SCR into conduction mode is not advisable process because SCR may be damaged. Understood or not? That's the reason why practically like this you can turn on, but practically this method is not preferable. That is applying breakdown voltages, applying breakdown voltage, that is forward breakdown voltage, bringing the SCR into conduction mode, bringing the SCR into conduction mode, that is forward conduction mode, is not a advisable process. Is not a advisable process because SCR may be damaged. SCR may be damaged. Now, how you can bring the SCR into conduction mode? If you apply breakdown voltage, SCR comes into conduction mode. But what I am telling here, it is not an advisable process. Then how you can bring the SCR into conduction mode? Without applying high forward voltages, to bring the SCR into conduction mode, a gate supply is connected. Then that mode of operation is nothing but a forward conduction mode. That is, in forward conduction mode, how we can bring the SCR into forward conduction mode means without applying forward breakdown voltage or without applying high forward voltages, to bring the SCR into conduction mode, a gate supply is connected. That mode of operation is nothing but a forward conduction mode. Understood? Now we'll see how it is possible without applying high forward voltages, only by connecting the gate supply, how it is possible to bring the SCR into conduction mode. Okay, that you go for another mode of operation, that is nothing but a forward conduction mode of operation. Okay, this about what exactly observations from the forward blocking mode. Okay, clear? Okay, all these points you concentrate in forward blocking mode of operation. Okay, now we go for another mode, that is nothing but a forward conduction mode of operation. Is it clear? See, for forward conduction mode, the another mode of operation is nothing but a forward conduction. Yes, without applying high forward voltages, without applying high forward voltages, to bring the SCR into conduction mode, to bring the SCR into conduction mode, a gate supply is connected. Now if the gate is connected, what happens? Under forward conduction mode, if the gate supply is connected without applying high forward voltages, how we can bring the SCR into conduction? This concept can easily understand by using switch concept. That already SCR is under forward blocking mode. J1 is closed, J3 is closed, J2 is open. Here we are connecting the gate supply. This current is IC. This current is AC. Okay. Now if gate is connected, what happens? Okay. SCR is under the forward blocking mode. Under forward blocking mode, if the gate supply is given to the SCR, what happens? Where VAK is positive. J1 is already closed, J3 is already closed, but J2 is open. Under forward blocking mode, if the gate supply is given, because of this gate supply, more number of carriers are injected into J2 junction. If the more number of charge carriers are injected into J2 junction, it's just like a doping. Extra carriers we are adding to the J2 junction. Once because of this doping concentration, what the J2 junction width reduces. Once the J2 junction width is reduced, then this J2 will be break down with high forward voltage or less forward voltage. Less forward voltage. Then SCR comes into, like this, we are bringing the SCR into conduction. This is idea behind connecting the gate supply. Under forward blocking mode, if gate supply is given, what happens? This is the concept. Whenever gate supply is given, more number of carriers are injected into J2 junction. Because of the charge carrier, J2 junction width is reduced. Then with less forward voltage, J2 is breakdown and SCR comes into forward conduction mode. Okay, that point you list out this. If gate supply is given, if gate supply is given, more number of charge carriers are injected into J2 junction. Due to this, J2 width is reduced, and with minimum forward voltage, okay, minimum forward voltage, SCR comes into which mode? Forward conduction mode. This type of triggering is called gate triggering. If gate supply is given, more number of charge carriers are injected into J2 junction, and due to this, J2 width is reduced, and with minimum forward voltage, SCR comes into forward conduction. Now the question is, sir, by connecting the gate supply, we are bringing the SCR into conduction mode. Is it possible without applying any forward voltage, only by connecting the gate supply to bring the SCR into conduction mode? Yes, it is not possible. That is, even though gate supply is connected, to bring the SCR into conduction mode, a minimum forward voltage must be required. That minimum forward voltage is called finger voltage. Understood? That means even though gate supply is connected, to bring the SCR into conduction mode, to bring the SCR into forward conduction mode, a minimum forward voltage is required. A minimum forward voltage is required. It is called finger voltage. It is called finger voltage. It is called finger voltage. This minimum forward voltage is called finger voltage. Concentrate. That is, you must connect gate supply, but some minimum voltage is required. This I represented here. Without any gate supply, this much of voltage is required to bring the SCR into conduction mode. For example, a small IC1 is applied. For IC1 current, this is IC1 current. This much of forward voltage is required. For IC2 current, this much of forward voltage is required. For IC3 current, this much of forward voltage is required. That means, if the gate current is increased, the forward voltage required to bring the SCR into conduction mode is reduced. Therefore, observation is, if the gate current is increased, the forward voltage required to bring the SCR into conduction mode is reduced. Then if you draw the characteristics between, gate current and forward voltage, then you get the characteristics like this. This is forward voltage and this is gate current, then you get the characteristics like this. Then this is the forward voltage required for IC1 current. This is the forward voltage required for IC2 current. This is the forward voltage required for IC3 current. Let this current is IC1. This current is IC2. This current is IC3. This is IC1. This is IC2. This is IC3. If the gate current is increases, forward voltage is required. Let this forward voltage is VF1. This forward voltage is VF2. And this forward voltage is VF3. Then what the relations here? Where IC3 is greater than IC2 is greater than IC1. Therefore, VF3 is less than VF2 is less than VF1. High gate current, less forward voltage. Less gate current, high forward voltage. Okay. Like this, we are bringing the SCR into forward conduction. Understood? Okay. But I want to extend this concept, important for any competitive point of view. Yes. Tell. Okay. We are applying the minimum forward voltage and connecting the gate supply and bringing the SCR into conduction. Okay. Now the SCR is conducting. Point to remember, once the SCR starts the conduction, when the SCR starts the conduction, whenever J2 is closed. If J2 is open, it is open switch, it is not conduct. Once the SCR is conducting means J1 closed, J2 closed and J3 closed. If all the junctions are closed means all the junctions are forward bias or reverse bias? Yes, all the junctions are forward bias. Very important observation. Once the SCR starts the conduction or during the conduction of SCR, all three junctions are forward bias. That is one point to remember. During the conduction of SCR, all the three junctions are forward bias. Okay. All three junctions are forward bias, SCR is conducting. But point to remember, once the SCR starts the conducting, gate loses its control over anode current. Once the SCR starts the conduction, gate loses its control over anode current. That means, by controlling gate current, we cannot control current through the SCR. We cannot control anode current through the SCR. Why? The reason is this one. Why the gate loses its control over the SCR means, whenever gate supply is connected, more number of charge carriers are injected into J2 junction. Once the more number of charge carriers are injected into J2 junction, that J2 becomes more saturated, then SCR starts the conduction. Once this J2 junction is more saturated, there is no control of gate on anode current. That means we can increase the gate voltage or we can reduce the gate voltage. The current to the SCR cannot be controlled. Tell. Okay. Once the SCR starts the conduction means gate losses its control over the anode current means is there any use of gate supply? I'm not talking about gate terminal. I'm talking about supply. Is there any use of gate supply? Yes. No use of gate supply. Then remove the gate supply. Sir, what happens if it is connected permanently? If it is connected permanently, it adds additional power loss. In order to eliminate that losses, remove the gate supply. That's the reason why. In detail later on I will explain. In the gate triggering pulses shown like this now, a triggering pulses are represented like this, or a gate triggering pulses are represented like this. What is the meaning of this? Once SCR is triggered, SCR starts the conduction, this gate supply is removed. Again you want to triggering means, again gate triggering is applied. Again it starts the conduction means, remove the gate supply. That's the meaning. No need to apply the continuous supply, continuous gate supply. If it is continuously gate supply is connected, it adds additional power loss. That you figure out. Is clear? Now see. That means once the SCR starts the conduction, all the three junctions are forward bias. Or during the conduction of SCR, all the three junctions are forward bias. Very important observation. During the conduction of SCR, all the three junctions are forward bias. Important point already framed in COM 2. All the three junctions are forward bias. Another point. Once the SCR starts the conduction, once the SCR starts the conduction, gate losses its control, over anode current. That means by varying the gate current, we cannot control the anode current. That's why when the SCR starts the conduction, gate losses its control over anode current. Then remove the gate supply. If it is connected permanently, it adds additional power loss. That's the reason why remove the gate supply. But point to remember, at the time of removing the gate supply, current to the SCR must be reaches a minimum value of current. Very important concept. Okay, SCR starts the conduction, gate losses its control over the SCR, then no use of gate supply, remove the gate supply. If it is connected permanently, it adds additional power loss. But at the time of removing the gate supply, current through the SCR must be, the anode current through the SCR must be, reaches a minimum value of current. That current is called latching current. If the gate supply is removed before reaching the latching current, then SCR is automatically comes into forward blocking mode. It cannot enter into forward conduction mode. That's why the latching current is reference for turn on of SCR. The latching current is a reference where you want to remove the gate supply for reliable turn on of SCR. Understood or not? That's why at the time of removing the gate supply, at the time of removing the gate supply. Removing the gate supply. Removing the gate supply. Removing the gate supply. Current through the SCR. Current through the SCR. Current through the SCR reaches a minimum value of current. A minimum value of current. Value of current. Minimum value of current is called which current? Yes, answer. Which current? Latching current. Very important. Latching current. It is the minimum current through the SCR at the time of removing the gate supply. It's called latching current IL. Therefore, latching current is associated with turn on process or turn off process. Yes, it is associated with the turn on process. If you want to make the turn on of SCR, then minimum current is latching current. Therefore, for example, if the gate supply is removed, if the gate supply is removed, if the gate supply is removed, if the gate supply is removed before reaching the latching current, before reaching the latching current, if the gate supply is removed before reaching the latching current, before reaching the latching current, then SCR is automatically comes into which mode? Comes into forward blocking mode. That means it cannot turn on. At the time of removing the gate supply, current through the SCR, which current? Anode current. This is anode current, point to remember. Anode current through the SCR must be reaches a minimum value of current is called latching current. If it is not reached the latching current, before the latching current, gate is removed, then again it comes into forward blocking mode. Therefore, latching current is associated with which process? Latching current is, very important point, latching current is associated with the turn on process. Associated with the turn on process. For turn on of SCR, the reference is latching current. Latching current is associated with the turn on process. Okay, like this we are bringing the SCR into conduction. Okay, we are connecting the gate supply up to latching current. After reaching the latching current, gate supply is removed, then thyristor is conducting. But we don't allow continuous conduction of SCR. The purpose of using any device between source and load means you want to control the power or convert the power. For example, here there is some load is there and here there is some supply is there. In between this we are placing one power semiconductor device. What is the purpose of placing any device between load and source? You want to convert the power or control the power. If you want to convert the power or control the power means continuously cannot allow the conduction. You want to make on and off control. Then only conversion and control is possible. Okay. If you permanently connected means, if you permanently you want to supply the power means permanently it is connected means, then what is the use of this device? You remove this device, just you connect one wire like this, then continuously power is flowing. Understood? The purpose of connecting any semiconductor device between load and source is you want to control the power or convert the power. If you want to control the power or convert the power means on and off control is required. Okay. Here SCR starts the conduction. After some time you want to turn off the SCR. again turn on the SCR, again turn off the SCR, again turn. This is not a manual operation. You want to make some automatic control by writing some program using microcontroller or microprocessor. Okay, SCR starts the conduction. After some time, I want to turn off the SCR. Then how you can turn off the SCR? By using gate supply, you cannot turn off now. Why? Gate losses its control over the anode current. We are remove the gate supply. Then how to turn off the SCR? Then to turn off the SCR, what you can do means, to turn off the SCR, a reverse voltage is applied. This reverse voltage is applied in two methods. If the available supply at input side is AC, the supply voltage at every negative half cycle, a reverse voltage is applied, then the device will be turned off. That commutation is called natural commutation. If the available supply is DC, in order to turn off the SCR, an external power supply you can use, an external circuit you can use. That is called forced commutation. In detail about that, later on I will discuss. But here I am giving how the thyristor is turned off. To turn off the thyristor, a reverse voltage is applied and current through the SCR reduced below a minimum value of current. That current is called holding current. See the significance of holding current. That is, if you want to turn off the SCR means reference current is holding current. That means to turn off the SCR, what you can do? A reverse voltage is applied. A reverse voltage is applied. A reverse voltage is applied across SCR. A reverse voltage is applied across SCR. And anode current is reduced. And anode current is reduced. And anode current is reduced below a minimum value of current. Below a minimum value of current. Below a minimum value of current. Below a minimum value of current is called which one? Holding current. Is called holding current. That's why if you want to turn off the SCR means we can reduce the anode current below a minimum value of current by applying reverse voltage. That is nothing but a holding current. Therefore, holding current is associated with which process? Turn on or turn off? Yes. Holding current is associated with the turn off process. Latching current is a reference for which one? Turn on. But holding current is reference for which one? Turn on. Okay. Therefore, holding current is associated with the turn off process. Holding current is associated with turn off process. Is associated with turn off. Like this, the turn on and turn off process can be explained. Like this, the turn on and turn off of SCR is explained by using modes of operation. That is nothing but a forward blocking mode, forward conduction mode, reverse blocking mode. Okay. We can make the SCR is conduction. Again, if you want to turn off the SCR means, again, we can reduce the current through the SCR below some minimum value of current. That is nothing but a holding current. Then holding current is associated with the turn off process. It's clear. Now, the point to remember in general, this very important points. In general, always latching current is greater than holding current. Very important relation. Latching current is greater than the holding current. And another point to remember, latching current is equal to 2 to 3 times of holding current, or in average, latching current is equal to 2.5 times of holding current. Latching current equal 2 to 3 times of holding current, or latching current equal to 2.5 times of holding current. Clear? latching current is equal to 2.5 times of holding current. This one relation. This about what exactly? Modes of operation are static VI characteristics of SCR. This is the holding current. We can reduce below some minimum value of current, that is nothing but holding current. This current is nothing but a latching current. The point to remember, if this forward current is continuously increased, the forward voltage drop is also increased. That is the on-state voltage drop is also increased. That's why the forward voltage drop or on-state voltage drop across the SCR is not constant. That depends on the magnitude of current passing through the SCR. If that current is increased, that forward voltage drop is also increased. Okay. This about reverse blocking mode of operation, and this about forward blocking mode of operation, and this about forward conduction mode of operation. Then what is the significance of latching current and holding current? Then in general, latching current equal holding current, latching current equal 2 to 3 times of holding current, latching current equal 2.5 times of holding current. Clear? This very important relations to solve the problems in any competitive point of view. Okay, that you will see in classroom workbook. What are the problems important based on this concept? Later on I will discuss. Clear? Okay. Then before going to the next concept with respect to thyristor, I want to make some note here. With respect to static VI characteristics, whatever the concepts I discussed, along with I want to make some note. This you remember as a note. Some important points. Already given so many points. Along with you also remember these points. Tell me. SCR blocks both forward and reverse voltage, but diode blocks only reverse voltage. That is the difference between diode and the SCR. That is, SCR blocks both forward and reverse voltage. Forward and reverse voltage. Reverse voltage. But diode blocks. But diode blocks only which one? Only reverse voltage. This is the difference between diode and SCR. Another point. SCR is a bipolar device. The conductivity is due to both majority and minority carriers. It is a bipolar device. It is a bipolar device. The conductivity takes place both concept of majority and minority carriers. It is a bipolar device. Understood? See, another observation. For reliable turn on of SCR, gate must be connected up to current through the SCR reaches to latching current. Gate turn on time or gate pulse width must be connected up to latching current. That is, for reliable turn on of SCR, for reliable turn on of SCR, for reliable turn on of SCR, gate must be connected. Gate must be connected. Gate must be turn on. Gate must be turn on. That is turn on. Gate turn on is nothing but a gate pulse width. Gate pulse width. Gate pulse width is nothing but a gate on time. Gate pulse width is nothing but a gate on time. Very important. Gate must be connected. Gate must be turn on up to latching current. Up to latching current. Okay, that is the gate pulse width you must connect up to turn on. Then only SCR must be reliably turned on. The question framing like this. For reliable turn on of SCR, gate pulse width equal to dash. Like that questions are framing. Reliable turn on of SCR, you find the gate pulse width. Gate pulse width is nothing but a gate on time. Gate pulse width is nothing but it is not a total time period. Point to remember, it is a gate on time. How much time gate must be on? Then you find the time corresponding to which current? Latching current. That gives the gate pulse width for reliable turn on. Clear? Next, another observation. Tell. Even though gate supply is given, even though gate supply is given or gate triggering is given, SCR will not turn on because what is the reason? What are the reasons? Even though gate supply is given, SCR will not turn on. What is the reasons? Tell me. Even though gate supply is given, even though gate triggering is given, even though gate triggering is given, SCR will not triggered, even though gate triggering is given, SCR will not triggered means it may be due to one reason. You are giving gate supply, but it is not triggered. What are the reasons? You tell. It may be due to SCR is under reverse blocking mode. SCR is under reverse blocking mode. That is one reason. SCR is under reverse blocking. This is one reason. Second one. Voltage across the SCR is less than the finger voltage. Voltage across SCR is less than finger voltage. That is not sufficient forward voltage. Less than finger voltage. If it is not triggered means maybe due to these reasons. Voltage across SCR is less than finger voltage. You tell me another reason. SCR is maybe under reverse blocking mode. Under reverse blocking mode, if you give the triggering pulse, is it SCR will trigger? No. Yeah. Voltage across SCR is less than the finger voltage. The another one is gate is removed before reaching the latching current. Gate supply is removed before reaching the latching current. Before reaching, anode current is reaching the latching current. That is, gate supply is removed. Gate supply is removed. Gate supply is removed before reaching. Gate supply is removed before reaching which one? Yes, latching current. Before reaching IL. Okay. And this about what are the reasons even though gate supply is given, SCR will not trigger. These are the reasons. Clear? Understood? Okay. This about static VI characteristics of a SCR. With this one concept in thyristor, starting I given some introduction, then these are the static VI characteristics of SCR. Then you go for another concept with respect to SCR, that is nothing but a turn on methods of SCR. Okay. This you concentrate. For example, if the question is framed like this, can you answer this one? For example, this is based on concept oriented. I am giving like this. For example, current through the SCR is SCR is conducting. If the question asks like this, SCR is conducting. SCR is conducting. And current through the SCR is. And current through the SCR is. And current through the SCR is. And current through the SCR is 20 amperes. If the gate current is reduced to 1/4, if the gate current is reduced to 1/4, then the current through the SCR is dash. Then the current through the SCR is dash. Then the current through the SCR is dash. Can you answer this question? SCR is conducting and current through the SCR is 20 ampere. If the gate current is reduced to 1/4, then the current through the SCR is dash. Yes. It is 20 amperes. The answer is 20 amperes. That is remains same. Remains same. Remains same. That is 20 amperes of current. Why? Yes. Condition is given. SCR is conducting and current through the SCR is 20 amperes. Conducting. When the SCR is conducting means gate losses its control over the anode current. When the gate losses its control over the anode current means we can increase the current or decrease the gate current. Is there any control on the anode current? Yes, there is no control. When there is no control means then current to the SCR remains how much? 20 amperes. Understood? For example, further question, if it is framed like this. This just for theory question I am giving based on this concept. The question is framed like this. Concept oriented. SCR is during the conduction of SCR. 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 Tell option A. J1, J3 forward bias and J2 is reverse bias. Option B. J1, J3 reverse bias and J2 is forward bias. Okay. Option C. J1, J2 and J3 is forward bias. Option D. J1, J2 and J3 is reverse bias. Condition is given. What it is given? SCR is conducting during the conduction of SCR. Then what is the observation? I told now, once the SCR starts the conduction, when the SCR starts the conduction, before conduction of SCR, J2 is open, J1, J3 is closed. But once the SCR starts the conduction means J2 must be closed. J2 must be closed means all the junctions are forward bias or reverse bias. Yes, all the junctions are forward bias. That is J1, J2 and J3 is forward bias. J1, J2 and J3 is forward bias. Okay, like this we can expect any theory questions. In some more questions I will discuss in classroom work. Just for concept point of view I am giving these two examples. Okay, these extra points you concentrate. These extra points you concentrate. Then what exactly forward conduction mode, and these relations are very important. These are 5-star relations to solve any problem. Okay. And then based on this concept, in the next session we will see some classroom workbook questions. Then you go for another concept with respect to thyristor. I want to discuss based on this concept how the questions are framing in various competitive exams. Okay, then you go for another concept. Okay, understood?